Okay, so we will have some questions now where we'll have to differentiate twice, so we get a thing called the second differential. So y equals 2x cubed plus 3x squared minus 5x plus 2, and we're asked to find dy by dx, which is the first differential, and now this is called d2y by dx squared. Okay, so that's how we say that, d2y by dx squared, and that's the second differential. So we differentiate once to get dy by dx, so we say 3 times 2 is 6, take 1 away from 3 and we get 2. 2 times 3 is 6, take 1 away from 2 and we get 1. Differentiate minus 5x, we get minus 5. Differentiate 2, we get 0. Then differentiate again to get d2y by dx squared. So 2 times 6 is 12. Take 1 away, it would just be 12x to the power of 1. Differentiate 6x, we get 6. Differentiate minus 5, we get 0. Our second one then. Okay, so y equals 3x to the power of 4 plus 2 over x to the power of 5 minus 3x, and again we're asked to find dy by dx and d2y by dx squared. So the first thing we're going to do is write this out in the format that we want to use. So bringing x to the power of 5 up to be x to the power minus 5. And now we're going to differentiate for the first time. Okay, so dy by dx, 4 3's, 12, take 1 away from 4 and we get 3. Minus 5 times 2 gives you minus 10. Take 1 away, remember being careful of the minus sign, so minus 5 minus 1 gives you minus 6. And then differentiate minus 3x, we get minus 3. Now normally if we're finishing the question there, I would tidy this up and put it over minus 10 over x to the power of 6. But because we're differentiating again, there's no point in tidying it up because we'd have to bring it back up again to be able to differentiate. So d2y by dx squared, differentiate again, so we say 3 12's, 36, take 1 away from 3 and we get 2. Minus 6 by minus 10 gives you plus 60. Take 1 away, we get x to the minus 7. And when we differentiate our minus 3, it's a constant, so it disappears.